Hello friends, welcome to the last lecture on integral calculus. In this lecture we are going to do definite integrals. Okay, so definite integrals that you have in CA foundation level, as I keep telling you, is a very simple elementary level. Okay, so whatever you have learned so far in the previous 7 lectures, it is only going to be application of that in definite integrals. Okay, let us take up the first question in the series. How simple this is. Okay, let's do question number 30. Look at question number 30. You have integral 1 to 4. Okay, we say how do we read it? 1 to 4, 2x plus 5. Integral 1 to 4, 2x plus 5. Now, this is called as the lower limit. This is called as the upper limit. Normally, we represent the lower limit with A and the upper limit with B. And how do we integrate this? For the time being, you forget A and B. Just integrate these two terms. Okay. What is the integration of 2x? All of us know that 2x is nothing but x square by 2. The 2 is a constant, so that remains as it is. We cancel both the terms and then we add integration of 5. Integration of 5, 5 is a constant, keep it as it is. Then when you integrate, what you get is a x. Please be careful that in definite integrals, we never add k. Okay. So after we integrate both the terms, we put this kind of a bracket and then we write 1 to 4. This, like I told you, this is A and this is B. Then what do? We substitute B. We do B minus A. Okay. We first take B and substitute. Then we substitute A and then we subtract the 2. Okay. So let's do that now. So x square plus 5x is what we have got. Okay. In this I'm going to substitute 1 and 4. How do we do that? 4 square plus 5 into 4. Put it within a bracket minus, open another bracket, 1 square plus 5 into 1. Okay. What is 4 square? 16 plus 5 fours are 20. Close the bracket minus, what is 1 square? 1 plus 5 minus 6. So 36 minus 6, answer is 30. So do you see how elementary definite integrals is? We did not learn anything new, a technique of integration. 2x plus 5 is a very straightforward question on integration. All you have to do is just substitute. So this kind of a question comes in the examination, straight 1 mark into your pocket. So do you find your confidence building up over these lectures? So don't be worried about integration and differentiation. What we have at the foundation level is very basic. Like you saw, we did not do any trigonometric function at all, and even the logarithmic functions we have done only the basics. Okay, so let us move on to the next question. Question number 31. Let us write down 1 to 2, 2x by 1 plus x square. Integral 1 to 2, 2x divided by 1 plus x square. Now when I have told you, when you have division of two terms, what you can do is always look at these two terms and check whether these two terms are in the format integral f dash of x divided by f of x. Correct? If this is the case, then the answer is nothing but log of f of x. Please write down this formula with a red ink when you're doing in your notebooks, because this formula is very important. We have done problems on this formula in earlier lectures also. You can go back and refer that. Now, in this case, our f of x function is nothing but 1 plus x square. Our f dash of x function is nothing but differentiation of this is 2x. So this exactly matches with the formula. So our answer is log of 1 plus x square. Close the mod. Now, like I told you, no plus k. We will not put that. We'll put the standard integrals 1 to 2. A to b. Let's substitute the value of a and b. 1 plus 2 square is 4 minus log of 1 plus 1 square. 1 square is 1. So we have here log 5 minus log 2. Now you can stop at this stage or look at the options and see how they are. Come to the options. You see the options, look at option B. It is log 5 to the base e minus log 2 to the base e but with a plus k. Whereas look at option A. Option A is log 5 by 2 to the base e. So I've told you in definite integrals we should never add plus k. So here we will have log 5 by 2. This is log m minus log n formula. Okay, let me write here. Log m to the base e minus log n to the base e is nothing but log m divided by n to the base e. So this formula I have applied here to the base e. So answer is option A. So please friends, look at two options are so similar. Option A as well as option B. So do not get carried away. Be very careful. The one with k we should not select indefinite integrals. Okay. Whereas when we do other integration problems, we should select only the one with k. Please keep this in mind and make a note of it with red pen if it is possible. Now let us try question number 32. So far friends, what I have done for you is question number 30, which is nothing but basic integration problem. Okay. Then we have done question number 31, which is integration by substitution also it can be done or using this formula. Question number 32 is nothing but integration of a function of a function. So let's see what to do in question number 32. In this question we have integral 0 to 4 root of 3x plus 4. Okay. Integral 0 to 4 root of 3x plus 4 dx. Let me just check the values once again. 0 to 4 is correct. Now integration of a function. Please remember this is nothing but a linear function. It's not a quadratic. If it is quadratic, then we will be using the standard integrals formula which we saw in the earlier lecture. Okay, so this is nothing but a linear function. In a linear function, all we have to do is assume the whole thing to be a capital X. And what is the integration of a capital X raised to the power of half? It is nothing but capital X raised to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1, which is nothing but X, or let me use the same letter here. It is nothing but capital X raised to the power of 3 by 2 divided by 3 by 2. The numerator I will take this 2. So this is what we get. Okay. So now I'm going to just repeat it here. 2 by 3. Capital X is nothing but 3x plus 4. Whole thing raised to the power of 3 by 2. However, this function x is accompanied, or in this function we have 3x plus 4. The small x is accompanied by a coefficient. The small x is accompanied by a coefficient 3. Therefore, I should additionally divide it. In differentiation, I used to multiply that coefficient in function of a function. In integration, I will divide that 3 in function of a function. Okay. Now let me put the bracket 0 to 4. 2 by 9. 3x plus 4. The whole power 3 by 2. 0 to 4. So let us substitute 4 first. See, this 2 by 9 is common to both 0 and 4. So you can keep it common. You need not take it within the bracket. Then your calculations will become more complicated. So let us avoid that. Now 3 4s are 12. 12 plus 4 is 16. 16 raised to the power of 3 by 2. Then minus 3 into 0 is 0. 0 plus 4 is 4 power 3 by 2. Now close the bracket. What we can do is, first, this is nothing but, you have learned a power m whole thing raised to the power of n is a power mn. right? So in this case, what we are going to do is 16 raised to the power of 3 by 2. I'm going to write it as 16 power half, whole thing raised to the power of 3. And what is 16 power half? It is nothing but 4. What is 4 cube? 4 cube is nothing but 64 minus, same thing is applicable for 4 power 3 by 2 as well. What is 4 power half? 2. And what is 2 cube? It is nothing but 8. So close the bracket and put a 2 by 9 which is there outside. What is 64 minus 8? It is nothing but 56. So here we are going to write 2 into 56 divided by 9. And what is 2 into 56? 112 by 9. Okay. So this is what we have. Let's look at the options. 112 by 9 is option B. Option B. Now the next question that we are going to do now is, let's look at question number 33 and 34. 33, 34, 35. All the three are definite integrals. So what we could do here is 33 and 35. I will leave it to your practice, self-practice. Although I'll give you a hint what to do. This x plus 2 divided by x plus 1, right? What you can do to this x plus 2 is split it as, let me show you here. You have integral x plus 2 divided by, this is question number 33, right? Divided by x plus 1. You split this as x plus 1 plus 1 divided by x plus 1, which is nothing but x plus 1 by x plus 1 plus 1 by x plus 1. Now this will get cancelled, it will become 1. Then you integrate these two terms separately. Okay. 34th question we will do now. One to e square dx by x into 1 plus log x the whole square. This question is a little more complicated, so I am taking it up for our classroom practice. Integral 1 to e square dx divided by x into 1 plus log x the whole square. Okay, this is going to be done by integration by substitution. So what we will do is, we'll say let 1 plus log x equal to z. Then when we differentiate both the sides, we'll get 1 upon x dx is equal to dz. So you have your dx and divided by x. So instead of that, we will put dz divided by z square. Now please remember, I have not put any definite integrals in both these places. I'll come back to it later. Normally when we do substitution, we also change the values of these two terms depending upon whatever is the value. This number 1 and e square is applicable for x. The moment you change it to z, the values will change. But I'm not doing that just to save time. In the sense, in the examination also, I would suggest that you do not do that extra step. Okay, instead just do whatever I am doing now. What is the integration of z square? This will be taken to the numerator, z power minus 2 dz. Okay, this is nothing but z power minus 1 divided by a minus 1. So it will become minus 1 upon z. So which is nothing but 1 minus 1 by 1 plus log x. At this juncture, you can put 1 to e square. Okay, now we will substitute. So minus 1 divided by, please remember here the log, the base is not mentioned. It is needless to say it is base. 1 plus log e square to the base e. This 2 will come out and it will come here. Okay, so I'm going to write here straight away and cancel this here. Okay, now minus of minus will become plus 1 divided by 1 plus log 1 to the base e. We all know the value of log 1 is always 0. So 1 plus 0 will give us only 1 in the denominator. 1 divided by 1 is 1. So this is what we have here for the second term. Now coming to the first term, log e base e is 1. So 1 plus 2 is 3. So what you have is a minus 1 by 3 plus 1. So what you get is a positive 2 by 3. Okay. So let us look at question number 35 now. In this question, you have x plus 1 into x plus 4 divided by root x. What you can do in this case is you can multiply x plus 1 and x plus 4, two linear terms. You will get one quadratic term, and then you can start dividing each of these three terms with root x. Then you will get three terms. For example, let me just show you here. Question number 35. Integral x plus 1 into x plus 4 by root x. What you can do is multiply these plus 4. I'm still because 1 into x, 4 into x, when you add both, you'll get 5x, and then when you multiply, you'll get 4x. Root x. Now you divide each of the terms individually with this. Okay. For example, 5x divided by root x is 5 root x plus 4 divided by root x plus the first term 2 minus half is nothing but 3 by 2. So x power 3 by 2. Now you integrate each and every term separately with the definite integral values here. Okay. So this is what I think you can do that as self practice. Let us go to question number 37 now. Question number 37. Let's write it down. Integral 2 to 3 f of 5 minus x dx minus integral 2 to 3 f of x dx. Okay, so now there is a property of integrals, definite integrals, which we will apply here. Integral a to b f of x dx is also equal to integral a to b f of a plus b minus x dx. Okay, so I'm going to apply this property here. So in the second term, I'm going to apply this, that is 2 to 3 f of 2 plus 3 minus x, 2 plus 3 minus x dx, and what you have here is 2 to 3 f of 5 minus x dx. Now you see that here it will be integral 2 to 3 f of 5 minus x dx minus integral 2 to 3 f of 5 minus x dx. You have the same term with a negative. So when you cancel the two terms, it becomes 0. So this is our final answer. Now as self-practice, you can do the following problems. Question number 12. Question number, sorry, not 12. 12 already completed, right? Question number 18, 19, 20. Question number 35 I have partially done, so you will have to do that. Then there was another problem which we had partially done. That is question number 33. So 33 and 34 partially done. You can do that. What about question number 25? 25 also you can try. Okay. So these are the questions that you can try, and again get back to me in case of any questions. With this, we come to the end of differentiation. I urge you all to integration. So I urge you all to practice these problems again and again, and then you will be able to gain a lot of confidence. And believe me, the level of difficulty in the examination for differentiation and integration is very, very less, or it's very, very elementary level of difficulty. So all of you can definitely do very well if you practice these 50 plus 50 100 problems. Okay, so thank you. I'll come back and meet you all again once again with the revision lectures. Good luck to you all.